Hey, all you cool cats and kittens. Welcome to week 3 of science distance learning. We're going to continue science this week. Last week we talked about food chains and food webs, and we had a quiz on those subjects. I want to make sure that you have completed that quiz. If you haven't completed it yet, make sure you're going back and completing it. um, so, the stuff that's going on today, um, like COVID-19, for example, we can link that stuff back to some things we're going to learn about in this class, specifically when we talk about carrying capacity. So you might be wondering, what is carrying capacity? Well, carrying capacity is simply the amount of organisms that an environment can handle. So it's the amount of organisms that the environment can hold. Um, this can be on a micro scale or a macro scale. You could look at it globally. So the amount of, I don't know, humans that the earth can hold, or you can look at it really micro, the amount of microbes in a certain organ of your body, for example. So it can go be big or small. You can zoom in or you can zoom out. So an example of carrying capacity. So a lot of you like to go and hunt deer every fall. Now, how would carrying capacity relate to that if we stopped hunting, right? Well, if you stop hunting, you create a big imbalance into these food chains and food webs that we've been talking about for the last couple of weeks. So if you didn't shoot the deer, they would quickly go to carrying capacity and cause a huge disruption with the producers because they'd eat too many of them. There's not enough predators to keep their numbers down. They'd quickly, after they've eaten too much food, they would just begin to starve. They'd go over their carrying capacity. The environment couldn't hold any more of them. Here I'm going to show you a couple of graphs that are really good at showing what carrying capacity is. So here is just a general graph about exponential growth. So this would be an organism's population compared to its carrying capacity. You can see here it's an exponential growth. It's not linear. A linear would be a straight line. Exponential means that it gets really big really fast. And this carrying capacity is this dotted line here. This carrying capacity is a threshold you can think of. It doesn't change very much. As this population gets higher, some things that affect where that carrying capacity is at is the amount of food, the amount of water, and the amount of shelter in the environment. Okay, if you increase the amount of food, water, and shelter, your carrying capacity is going to go up. If you lose a lot of food in the area, your carrying capacity is going to go down. So what happens if you overshoot this carrying capacity? Remember, this line, carrying capacity, is the amount of organisms an environment can hold. Well, if you overshoot it, the environment can't hold any more organisms. They're going to die off. Now, either this is because there's so many organisms tightly together, they're interacting so closely that there's a virus that causes them to die off, or possibly they've eaten their food supply. They can't handle any more organisms, and some starve. So those are some examples of a die-off. So after you overshoot this carrying capacity, you have to get the population will go back down below the carrying capacity with the die-off. You can see that it rebounds and fluctuates. So after these animals die off, they reproduce, they shoot back up here, but they still, the environment can't hold them. And here you can see that it's a degrading carrying capacity. That means that this population is causing the food supply to start going down. It can't carry as many animals as it used to, so your carrying capacity goes down, leads to larger die-offs, and this population ultimately goes down to where the environment can sustain it. I'm going to switch gears here and look at a human population graph. As you can see, this starts at 8,000 BC, so about 10,000 years ago. The population, as you can see, is very low. If you look here, this would be 1 billion, 2 billion, 3 billion. It's way below. It's maybe like 1 million here. Okay, it's staying really low throughout history as we have some advancements in technology and new ways of growing agriculture, things like that. Our population is staying pretty low, but it's starting to increase a little bit. Some blips here. The population keeps increasing really slowly. The population hasn't even broken a billion yet. And here you can see the really big blip. The only really big blip we see in this whole thing is due to the plague, the Black Death, what have you. Back in the Middle Ages, that virus went through and killed a bunch of people. So as we get closer to present day here, our population skyrockets, right? We reach a billion people not that long ago, and it's just been climbing ever since. And here, this is an outdated graph. At the year 2000, we're at 6 billion, and now we're even closer to 8 billion people. So a big question that you guys are going to have to answer later for this assignment is, what caused this huge giant jump in population for humans? Okay, so this video shows the world population and how it's changed through time. So let's quick watch it here.
An environment is a system of living things. The Earth is our environment. The capacity of our environment to provide space, to produce food, and to supply energy are all limited. Humans thrive on less than 17% of the Earth's surface, and only about 4% will grow crops. We depend on these limited resources for our survival. Yet we are increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 CE to the present and project our growth into the year 2050.
Okay, so like he said, we're starting at 1 CE, which is like year 1. That's about 2020 years ago. We're going to go till now. We're looking at the population of humans, and then it's going to project it to 2050.
Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. Historical references will be provided by images and text at the bottom of the screen.
Okay, so be looking down at the bottom of the screen to look at the historical references to see just some general things that are going on. So early on here, the 1st century, the Han Dynasty is out of China. The population is staying pretty low and pretty stable, pretty consistent. Roman Empire, couple hundred years in, our population still staying pretty low and consistently the same low number. We're about 500 years in. Our population really hasn't changed a whole lot. Not going up a lot, not going down a lot, staying pretty consistent. Okay, we're a little bit more than 800 years in. We have the Viking conquest going on. Ragnar's going all over the world. Population still staying about the same. It's not really going up a whole lot, not going down a whole lot. We have a few new dots, but it's about stable. Thousand years in, our population is still pretty much the same. 1,300 years in, we see a lot of these dots starting to go away. That's because of the Black Death, as you can see down here. The Black Plague, the plague or the Black Death wiped out a lot of the population on Earth. We're at the height of the Incan and Aztec empires. We still only have about 2 million people in the U.S. at about 1,600 years in. Europe's starting to explore the world. We have the Atlantic slave trade going on between Africa and the Caribbean and Europe. Our population is starting to get bigger, but it's still pretty stable. Not a huge jump yet. Okay. Here's a big one, Industrial Revolution. We hit 1 billion people here. We see a huge increase in the population as the medicine gets better, modern medicine. A couple world wars, that doesn't really help. We're at 4 billion now, the Green Revolution, meaning better farming equipment. Now we're at 7 billion, projecting 8, projecting 9. Where are we going to be in 2050?
Our population is expected to grow to 10 billion by the end of this century. Yet the Earth's size remains the same. Slowing human population growth and lowering our use of natural resources are key to reducing the impact we have on the planet. Through the decisions we make about our lifestyles, our numbers, and our consumption, we can all help preserve the health and beauty of our home.
So as our population on Earth gets bigger and bigger, we can see that if we overshoot our carrying capacity, which is disputed by lots of different people. Some people say that we're nearing it now. Some people say that we still have a few more billion people that we could pack on this Earth. Something's going to have to give, right? If you get past that threshold, get past the carrying capacity, there's probably going to be viruses or starvation because we can't feed all the people on Earth or pack so tightly together that we're passing viruses around. Some people now are even saying that coronavirus, since we're packed so tightly now and we can't stay 6 feet apart from each other very easily, that might be a factor for carrying capacity, right? The virus is getting passed around quite a bit. Okay, so for the rest of this lesson, you're going to be using this website. So you're going to want to come up to menu. I want you just to kind of cruise around the website. You can look at exploring the map and timeline. If you want to know how to use it, you can click here. Population readings and tools. I'd suggest going to here, explore the map and timeline. We've already watched the video, so just go to explore the map. And here you can look at a bunch of different things. So you can go forward in time here to different events, and it'll show the year change and then the population change with the year, some different events here. You can look at the overlays, human land use. It shows the land use at a different time in history. Mess around, use this website to answer the questions on Google Classroom. If you have any questions, feel free to shoot me a message. I'm usually pretty fast on the email. So if you have any questions, feel free to let me know. I hope you guys enjoy the website, and let me know if you have any questions. Have a good week.